Hello everybody, it's old Shazizz here. I'm out here in my mad science laboratory. So worst case scenario, you need to get some water up out of a well and pump it uphill or something like that, but you have absolutely no electricity. And there's all kinds of different manual ways, bucket, carried up the hill and all that kind of stuff. But using the pop boat, which we do have a contest still up going to see who can build the biggest and the best pop boat and the fastest and all that kind of jazz. But using the basic science that comes from that, and while I'm talking about that, let me give you a sneak peek at my pop boat. Alright, well, keep in mind I took absolutely no pride in the paint job and the body work on this thing, because what I did was I set fire to it the first go. While I was working on trying to seal it up, that little deal right down in here. Let me switch my hands around. Right down in here, that little deal right there is the motor, and there's the two little lines coming out the other deal. Now I have tested this out of the water. It does spit water out, but I haven't tested it in the water, so I don't know if it spits enough water out to actually move this boat. But if it does, it'll be pretty impressive, because it's made out of galvanized sheet metal. And you can obviously see that I did no measuring. I just kind of like cut and snipped and tucked and riveted and body puttied. And you see this nice sand job that I did on there. It's I took absolutely no pride in painting it. Matter of fact, if you was to be riding in my pop boat to go for a joyride, this is the view you'd get, because I accidentally got some freaking paint on the windshield. And there's the motor. Doing, can't even get it. There it is. There's the motor. It's a coil with some melted solder inside there to hold in more heat. So anyway, that's that. We'll find out if she floats, and if she does float, we will then find out whether or not she will move. So, not every project ends in a success, but we will find out. Alright, now let me get on to this before I waste too much time and my doggone antivirus is aggravating me again, telling me I got to update. Yeah. Alright, so you say you got to pump some water and you have no electricity, so this is what I've been working on, using what I've learned from the pop boat and the doggone siphon effect that you use to siphon water or fuel or whatever. If you look down inside there, see it's already dripping. I've got a little bit of alcohol in a little container down here that I'm heating up the water, and the coil actually setting below the water levels. And so since we know that water will always find its level, that coil will always stay full of water. And then we have the alcohol burner down here that I'm going to move a little bit more over here towards the front. For some reason it likes that front deal, but you can see it's starting to push water up over the top. No, so what we got going in is water finds its level. We're heating up the water. We're creating a steam pocket in there. We're forcing the water up through. This little gizmo right here is a check valve out of a coffee pot to allow the water to only go one direction. And then what we got is when the water gets up over this top right here, falls down the spiral, pools up down there, and drips out that deal right there. Now I got a better design on the way, as far as I want to put a condenser on there at the top, so there will be actually a coil here going this way, and then up here will be another coil going that way, and then straight down will be the spiral coil. See, the trick is you want that continuous drop down there. You don't want it to have any places, any high sides on there, so don't have to work as hard to get the water over the hill. And let's see, I moved my fire again. It's either that or I'm there. Okay, you can see the water starting to push up the hill, and it's kind of cold out here, so it's taking a lot longer to actually get this doggone thing to do something. So anyway, while I'm at it, I put 3 thermocouples on here that are in there, and you can see that those 3 thermocouples, and keep in mind it's only in the millivolt range, but it's actually generating a bit of electricity. So with a little modifications, you could actually design this to be a lot better. You could generate a little electricity while you're pumping water, heating water, and maybe even purifying at the same time. So what I thought would be good about this deal was, you know, in third world countries where they don't actually have access to electricity, you could build a well beside a well and put your heating unit down there, burn wood or coal or whatever to heat the coils up, pump the water uphill, and then spiral it down into whatever container you're going to use. So you could get warm bath water, fresh drinking water, and you know, maybe some good things out of that whole deal. So anyway, while that's let me do something here real quick. I'm gonna get a little crazy. I'm gonna move my alcohol burner because this is taking a long time to do what it is that I'm trying to do, and so I'm gonna try not to blow the house up, try not to blow the mad science lab off its foundation. And I'm gonna hook my little propane torch up here, see if I can do this without blowing things up. See if I could speed that heating process up just a second, just long enough for you to see when that coil gets hot. Notice my voltage is going up over here. Doggone it. Voltage going up. Alright, now we can see the water going up faster now. Come on. Gotta hold my torch steady. Alright, just give me one good spit out of there and I'll turn this torch off. Now I'm saying that the trick is going to be getting the temperature pretty much just to the right deal, having a bigger coil. And keep in mind, I can't keep this torch on there too long, but you can see it's actually pushing the water up there. Doggone it. Yay! Spitting water out everywhere. Too much heat. Now I gotta get my torch to shut off. But if you look down there at the voltmeter, it's still dropping fast, but we were actually producing a little bit more voltage with the hotter deal going on there. Let me see if I can get my little alcohol burner back in there and save a bit of what heat was going on. It's so cold out here, alcohol don't want to burn very good in the cold. Alright, well, doggone it. I guess I'll have to cheat again. Put a little bit of alcohol on that wick. Getting alcohol everywhere. I'm going to start a forest fire. Doggone it. Alright. Now speeded up the heating process a little bit. One thing is, copper is a good conductor of heat, that's for sure. So with that said, let that sit there and cook for a bit. Alright, now you notice if you look over here, I still got my thermocouples. They're putting out a little bit of juice. Now thermocouples usually only go like to about 30 millivolts, somewhere around about, but they got thermal piles that you could probably get a little bit more, and Peltier elements that you could probably get a little bit more. And while that thing there's trying to get its momentum back, I will show you this. Alright, here's a little simple idea that I drew up last night. This right here would be a copper cylinder with a screw-on cap that has a seal in it, you could put you some canned heat down inside there, and then whenever you push this down, put this down in your creek or your pond or well or whatever, your water would go in this side right here, go around the coil, get heated up, and the heat would be also heating this coil as well. Then the water would spit up through the top through your hose, and then that down on your downward spiral into whatever container you were going to keep it in. So I wanted to share this little drawing with you that maybe you could sit there and tinker around with and see if you can perfect. There's probably a lot of different ways that you could actually make this better, but it was just a spur of the moment idea using what it was that I was doing with the deal you've seen in the video so far. So with that said, peace and love everybody. Get back to the video there. Take care. Possibilities, different ways that you could do it to be more efficient or whatever. But you can obviously see right there, it is pumping water up. It's not super fast. You know, like I said, you've seen whenever I put more heat to it that I got more pressure behind there. You don't want too much pressure, and actually you could probably make that coil a little wider, and you know, use instead of thermal couples, use thermal piles. But you know, there's some voltage coming out there, so you're producing a little bit of electricity, you're pumping water, you're heating water, and potentially even sterilizing the water as well, because I hope I'm not saying it wrong, but if I'm not incorrect in my deal, I believe I heard somewhere that copper has a little bit of antibacterial qualities to it, so it actually helps clean things up a bit. So anyway, there you go. That's a cheap, easy, backwoods method by which to pump water, and if you tinker around with it, you'll probably get it to do better than what I've done so far. But all I had at my disposal was this cheapo stuff right here. What I need to do is go get some more copper tubing and make this all one solid deal, where I got a my heating coil down here, and then I'll have my up here I'll have a condenser coil go in the opposite direction, kind of cool it down, the steam, flash it back into water, and then over the top of the hill my spiral coil going down. So you'll have water finding its own level, you'll have the pressure of the heat forcing the water up, then you'll have a check valve to where the water can only go one direction, and then you'll have a downward spiral keeping a continuous drop as you're going down. That's the trick. You don't want it to have to go over too many hills. Like you can see the water right now, when the pressure is coming up, it's forcing itself up over that hill, and then it goes down the downward spiral. And the longer I leave this running, get it to the right temperature, then I'll start seeing my water dripping down out the bottom down there, and sometimes it'll actually get to squirting out pretty good. But for a coffee can, some hot glue, and some doggone copper tubing, it's a pretty nifty little idea for pumping water without electricity. So hope y'all liked the video, and I'll keep working on this particular idea, and probably get some more copper tubing and do a little bit nicer deal. I couldn't put a whole lot of heat to this thing like you seen with that doggone torch because of obvious reasons. I got hot glue right there, and most of the heat starts backing into the doggone can and boiling the water from the inside out, and that's not exactly what I wanted it to do. But worst case scenario, you could speed the process up by adding a little bit more heat. So let me see there. Get it just in the right spot. Come on, just give me one good one. I'm shaking the heck out of everything. think I might be melting my hose. Doggone it, come on. There we go. Got a little bit of water coming out. I thought. Alright, in that particular system, that's just too doggone much heat. Come on. Alright, well, I'm running this video long, so anyway, it's just an idea. No, only bad idea is the one you don't put out there for somebody to try to see if they can fix it better. So stay tuned and check out the Pop Pop Boat contest, and hopefully you'll put one in there and all that kind of jazz. And peace and love, everybody. Take care.